Well, let's take a look at 2x plus 3y equals 10. If we were to graph it, it should look exactly like this. And I kind of cheated, plugged it into a graphing generator, gave it the equation, and then suddenly I was able to see where the line would come up. You can see right here at this point at negative 1, 4, and at 2, 2, it would actually make this equation true, because 2 times 2 is 4, and 3 times 2 is 6, and 4 plus 6 is 10, so we know this one is correct. And then if we plugged in the negative 1 for the x value from this point here, 2 times negative 1 is negative 2, and 4 times 3 is 12, and negative 2 plus 12 is 10, so we know this one is also correct. So we know that this line is actually representative of the equation. Now, the big question is well, how can we do it? A lot of people, they would flip it over to the slope-intercept form. You know, you would minus 2x from both sides, and then you'd be left with 3y equals negative 2x plus 10, and then you just go and divide by 3, and we get that slope-intercept form equation right there. This would be the same thing as 3 1/3. And let's just take a look at this line. You can see here's 0, 1, 2, 3, and then it's a little bit less than half. It's right at the 1/3, but that's very hard to graph. So this one's probably not the best solution to go about figuring it out, unless you actually started trying to plug in different values to see what could get you at a next XY table. So let's go set up an XY table and see if that one would work a little better. We know that if I plugged in 0 for x, that goes away, and we're left with positive 10/3, which doesn't give us anything nice to graph with. So let's just put a sad face right there, because it's not that helpful. But the next thing I would always encourage you to do is put in a 1 or a 2. So let's put this one in. Here's a 1, and 1 times negative 2/3 is negative 2/3. So we've got this idea going on, negative 2/3 plus 10/3. Well, they have the same denominator, so negative 2 plus 10 would be 8. So that's the same as 2 2/3. And if you look at it, sitting here at positive 1 for the x value, it does go up 2 2/3, and you can see it's hitting right there at 2/3. But again, that's very difficult to graph, so we'll just say, well, that's not too helpful. Next up, we'll go ahead and we'll try putting in a 2 for the x value. And this is where we start to get a little bit more help. 2 times negative 2/3 is negative 4/3. So what's negative 4/3 plus 10/3? Well, that's negative 6 over 3. What's negative 6 divided by 3? Negative 2. So, and as I look at the graph, it should be 2, 2, and so I'm going, well, where did I make a mistake? Negative 4 plus 10 should be positive 2. And 6 divided by 3 is positive 2. So this one we actually have. So that's one way that you can start going through and graphing these very stubborn and frustrating problems that have the weird y-intercepts with the slopes right here. But then we have one other way that we can do it. And by the way, once you get up to about 2 or 3, then I would start going back through the negatives. Probably after 2, I would have done negative 1, because usually after I go through 0, 1, and 2, I flip back to negative 1, and it would have gotten us positive 4, and then you would have had 2 points to graph it, and you would have been good to go. But let's try one other way. The other way would be if we just took a look at the standard form equation and we used a guess and check with that. So if we plugged in 0 for x, what we have is an equation where we can go solve for y, and that would let you be able to set up your xy table again. And this might make it a little bit easier because you don't have any type of fractions to deal with. 0 times 2 is 0. And now, since nothing's there, it's like, well, no sense putting that, just divide by 3. And again, when x is 0, we would still wind up with y equals 10/3. And that part's a little frustrating, I understand that, but it's just a little bit of patience. And if you come back through and then you're like, well, let's try 1, let's try 2, watch what happens whenever I plug in 2, because we know that the y value should be 2 also. Just take a little bit of time, don't rush it, just have faith that you can figure it out, a little bit of perseverance, and you get there. And as you can see, without having to fight with those fractions, it actually gets to be quite easy to figure out that y would equal 2 when the x is 2. So when x was 2, the y is 2 also. You go, put the point down on the graph, and then you keep on digging until you can find those other nice points. But actually, remember, because you've probably gone ahead and did your slope-intercept form, there is a shortcut once you find one point. Since we'd already figured out that the slope was negative 2/3, well, guess what? As soon as you have this one point, you can just say, well, down 2 and over 3. Down 2 and over 3. And you can also reverse it and go up 2 and back 3. Up 2 and back 3. And now you've got plenty of different points that you can plot on those graphs. So, you know, I kind of like the guess and check method to get you one point. And then if you can easily convert it to the slope-intercept method, really all you need is your slope, and then work from that one point that you know is true, and that lets you be able to graph the rest of the line. Hope it helps. If not, let me know.